Hello, so in today's lesson our learning target is I can solve single variable absolute value equations. So if you recall in our last lesson we just kind of did an introduction to what an absolute value is, kind of the basics of what absolute values are all about, and did some really simple examples of basic equations that use absolute values. So today we're going to jump into some more complex algebraic equations and how to solve them. So I'd like to start with an example. For our first example, we'll do absolute value of x plus 4 is equal to 7. So in this case, our absolute value is already isolated. So we say that it's isolated, meaning that on this side of the equation, the only thing there is the absolute value. It's not multiplied by anything, it's not divided by anything, there's no numbers being added or subtracted to it. So once our absolute value is isolated, which it already is in this case, we can split it into two different equations. So we will have our positive case, where literally all we do is take away these absolute value brackets. We get x plus 4 is equal to 7. And then we have our negative case, where we leave one side of the equation the same and take away the brackets, but we're going to make the other side negative. And now that we have these two equations, we just solve each of them. So it's just like a regular equation. We subtract 4 from each side, and we get x is equal to 3. In our negative case, we're going to subtract 4 from each side. We get x is equal to negative 4 minus 7, which is equal to negative 11. So you notice that this problem has two answers. We can check our work by plugging them back into our original equation. So the absolute value of 3 plus 4 is equal to the absolute value of 7, which is indeed equal to 7. In this case, we have the absolute value of 11 plus 4, which is equal to the absolute value of negative 7, which is indeed equal to 7. So both of these solutions work, and so that's why we celebrate with a happy face. So that is one example. So notice we start by having the absolute value isolated, and then we split it into the positive and the negative case, and we're just going to get two answers. So now let's look at another example. We'll call this one example number 2. So this one we're going to do x minus 3 is equal to negative 4. So I'm just going to start out like I did the last time, right? We're going to split it into positive and a negative case. We get x minus 3 is equal to negative 4. We get x minus 3 is equal to negative times negative 4, which is positive 4. So on this side, we're going to get x equals negative 1. On this side, we're going to get x equals 7. Okay, so we got our answers, right? X equals negative 1, x equals 7. So let's just, to make sure we did it right, let's plug in our answers into the original equation. We get negative 1 minus 3 is equal to negative 4. And wait a second. So you notice getting absolute value of negative 4 is equal to negative 4. So if you watched the last lesson, this situation should be slightly concerning to us, because we can't have the absolute value of something be equal to a negative number. It has to be positive. So we're going to get a sad face. Let's look at the other one. If we plug 7 back into the original equation, we're going to get absolute value of 4 is equal to negative 4. Same scenario. That doesn't work. So what we know now is this equation actually has no solutions. So that's what you write down as the answer for this equation. So we could have saved ourselves a bit of grief by right from the start looking at this and saying, hey, this absolute value cannot be equal to -4 because this cannot be equal to a negative number. So we could have said right from the start that this has no solutions. And that's just something to always look at in an absolute value equation, is right from the start, look at it and say, is it possible? In this case, we'd say yes, an absolute value can be equal to +7. In this case, no way. So just be on the lookout for those questions, because it's really easy to forget that, especially if you're doing a long problem set or you're doing a test and you're just doing lots of problems. It's really easy to forget that right from the start we know that this equation has no solutions. So those are our first two examples. Let's do another. So let's do 5 plus absolute value of 5x minus 3 is equal to 5. So you'll notice something slightly different about this equation, which is that the absolute value is not yet isolated. So before we split our equation, we're going to need to subtract 5 from both sides. We get 5x minus 3 is equal to 0. So in this case, if we split our equation, we get 5x minus 3 is equal to 0, and we get 5x minus 3 is equal to -0. And wait a second, 0 and -0 are the same thing. Multiplying 0 by -1 or dividing it by -1 doesn't make a difference. So if we have something in an absolute value that's equal to 0, we just have to solve one of the equations. So we get 5x is equal to 3. If we add 3 to both sides, if we divide both sides by 5, we would then get x is equal to 3/5. And that equation only has one solution. So you might be getting the idea now that absolute value equations, let's write it down, equations can have either 0, 1, or 2 solutions. So most of the ones that we're going to explore in this class are going to have 2 solutions. But be on the lookout for those ones that have no solutions, and also be aware that if your absolute value is equal to 0, there's only going to be one solution. And additionally, there are other cases that we're going to explore in just a few minutes in which we will also get one solution. So just be aware that absolute value equations can have either 0, 1, or 2 solutions. So now we're going to move on to number 4. For number 4, we're going to say -1/6 times 2x plus 4 is equal to -3. So we start out kind of similar to the last one. Our absolute value is not isolated yet. And you notice, our absolute value is equal to a negative number. However, our first step in this problem to get rid of this -1/6 is going to be to multiply each side by -6. That's going to get rid of this. We're going to get 2x plus 4 is equal to +18. And you notice now that we've isolated our absolute value, it's equal to a positive number. So that's good news. We're in business and we can keep going. So now we're going to split it into the positive case and the negative case. positive case, we get 2x plus 4 is equal to 18. Negative case, we get 2x plus 4 is equal to negative 18. Subtract 4 from each side, we get 2x is equal to 14. Divide by 2, we get x is equal to 7. In our other case, subtract 4 from each side, we get 2x is equal to negative 22. Divide by 2, and we're going to get x is equal to negative 11. So, if we wanted to check our work, we could plug it into the original equation. We would get negative 1/6 times 2 times 7 plus 4. This is going to be 14 plus 4. We have negative 1/6 times the absolute value of 18. Absolute value of 18 is 18. So negative 1/6 times 18, which is equal to negative 3, which satisfies our original equation. So notice again that it was okay in the start that our absolute value is equal to a negative number because we multiplied the whole of the absolute value by a negative fraction. So I just checked our answer to confirm. If I were doing a thorough job, I'd check this answer too, but for the sake of time and so that we can get to some more interesting problems, we're going to move on from this one. So just let you guys look at that for a second. And now we have 2 more problems to do. In our first problem, so this is number 5, right? We got 2 times the absolute value of x minus 6 plus 7 is equal to 23. So in this case, we have some work to do before we split. So we have a plus 7, and it's also multiplied by 2. So I'm going to start by subtracting 7 from each side. We have 23 minus 7 is equal to 16. Now we're going to divide by 2. We get x minus 6 is equal to 8. Now that we have it isolated, we can split it, the positive case and the negative case. So we get x minus 6 is equal to 8, and x minus 6 is equal to negative 8. We add 6 to each side, we get x is equal to 14. If we add 6 to the other side, we get x is equal to negative 2. If we check our answers and plug them into the original equation, so 2 times 14 minus 6 plus 7 is going to be 2 times the absolute value of 8 plus 7. It's going to be 16 plus 7, which is equal to 23. We are happy. We plug in a negative 2. We're going to get 2 times the absolute value of negative 8. So that would be a negative 2 minus 6 plus 7, which the absolute value of negative 8 is going to be a positive 8. So once again, we're going to get 16 plus 7, which is equal to 23, which makes us happy. So that is example number 5. So that one was kind of similar to the last one. It's just that we had 2 steps that we had to do before we were able to isolate the absolute value and split it into our positive and negative case. So now I have one more example that I wanted to do today. So this is going to be our trickiest one yet. And this one is x minus 4 is equal to negative 2x plus 17. So you might notice in this case we have both an absolute value with an x in it, and we also have an x outside the absolute value. So this case, our absolute value is already isolated for us, so that's good news. so we can split it right away. Split it into our positive case, and we're going to split it into our negative case, where we get x minus 4. Here, this is important here, is going to be equal to negative times negative 2x plus 17. So let's do this case first. We're going to add 4 to each side. We get x is equal to negative 2x plus 21. Now we're going to add 2x to each side. We got 3x is equal to 21. Divide each side by 3, and we get x is equal to 7. Now we're going to look at this one. Our first step is we need to distribute this negative sign to both terms. So we're going to get x minus 4 is equal to positive 2x minus 17. And then once again, so if I subtract x from each side, we get x minus 17 is equal to negative 4. And then if I add 17 to each side, I'm going to get 13 is equal to x. But our work is not yet done. So when we have another x outside the absolute value, we must check our answer. So this isn't optional. It's not just good practice. There's a chance that one of our solutions is not going to work, and we're going to have to eliminate that answer. So let's check it out. The absolute value of 7 minus 4 is equal to negative 2 times 7 plus 17. So in this case, this is going to be the absolute value of 3. Is that going to be equal to negative 14 plus 17? We're going to get absolute value of 3 is equal to 3. That is correct, so we draw a smiley face, and we can circle our answer. So x is equal to 7 is an answer to this equation. Now let's look at 13. We have 13 minus 4 is equal to negative 2 times 13 plus 17. The absolute value of 7 is equal to negative 26 plus 17. Absolute value of 7 is equal to negative 9. Is that true? Not in this universe. So then we have a sad face, and this is not a solution. So the answer to this problem, we only have one solution. And x equals 13 is what's called an extraneous solution. And what that means is we did everything right in the problem-solving process, but when we checked our work, the solution just didn't work. So this is why it's really important in this case to always check your answer. So yeah. So that concludes our lesson on solving